So going towards the right, on this, for this one, the limit is approaching 7. Notice this dotted line. You guys know what this dotted line is? That's an asymptote. So if you actually find a value here, that is an asymptote for this dude. Now remember, horizontal asymptotes are not like brick walls. Vertical asymptotes are like brick walls. If there's a vertical asymptote, the function will not go through it. It'll be like, it'll go up like that if there's a vertical asymptote. But horizontal asymptotes, you can go through it like it's going right there. But in the end, on the horizontal asymptote, the function is always going towards it. So I guess you can say the function is attracted to asymptotes. You guys got that? Functions are attracted to asymptotes. All right, let's go to the negative side. So we're going to go to the left. What is my answer for this function right here? What are we going towards? 3. Okay, so as we approach infinity, whatever answer we get, our answer is an asymptote. It's a horizontal asymptote. All right, so think about this function right here. Do you guys know what e to the x is? What it looks like? Now there's a -2 right here, which shifts this function. What would the limit as we go to negative infinity be approaching for f if it looked like that? Take a minute and ask your teammates, see if they know. Graph it! That's what you got to do. You got to visualize this graph. Okay, so regular e to the x goes like this. Right? That's an exponential function. Regular one is right at the asymptote like this. But because of this -2 that shifts it, so my function is going to go down to, what is that asymptote at, that horizontal asymptote? It is at -2. Okay, so if we're going to the left at negative infinity, okay, we're going to the left, what is this function approaching? -2, and that's your answer. That is your answer. Oh. Okay, so what if we take the limit of this function, same function, but this time we go towards just regular infinity? That would be which direction? To the left? Nah, to the right. So that means we'll be going this way. What's the answer going to be? What is our function approaching? And positive infinity, okay? That tells you which direction it's going. It's going up, okay? So it's going up towards infinity. Our answer is always from the y-axis whenever you do limits. So this is approaching positive infinity. This over here is approaching -2. Notice our answer is from the y-axis for each of these. Now this is infinity. You'll never see a multiple choice question like this that will give you the answer of infinity and does not exist. Because some would argue like, oh, it technically doesn't exist because infinity is not a number. Okay, so here is a bunch of information I'm slapping on the screen that you guys are like, whoa, what's going on? So let me cover some stuff up. All right, so let's just start with this one. The limit as the limit of x to the n as x goes to infinity is infinity if n is greater than 0. Does that make sense? Is that always going to be true? Yes, no? I mean, whatever power you put onto this x, will we always be going to infinity as we are going to the right side of the graph? That's what x goes to infinity means. That means the right side of the graph. Will it always be infinity? Let's see. Look at this example right here. You see this blue one? That's x to the 4th. That's a positive exponent, right? N is greater than 0. So if I'm going to the right side of the graph, am I going to infinity? Yes, we are going to infinity. So as I'm going this way, this graph is pointing up towards infinity. And so that holds true for that one. And it also holds true if it was a 2. Look, that's a 4, that's a 2. They're both greater than 0. What about a 5 and a 3? Yeah, they're both going towards infinity. What do you guys notice right away? What if this was not positive infinity? What if that was x approaches negative infinity? Is that still true? Like, can we always say this? Can we say that it always equals positive infinity as we go to the left side of the graph? No. We can't always say that. Tell your neighbors right now why we cannot always say that we're going to positive infinity as we go to the left side of the graph. So I heard some of you guys say, well, when we have an odd exponent, like see how this is 5 and 3, and when we go to the left side of the graph, where are we approaching?
Negative.
Yes, okay. I mean, that's pretty simple. I'm not like trying to be tricky or anything. I just want you guys to think about that for a second. Oh, okay. So this is not true. What I just wrote, as x approaches negative infinity, that is not equal to infinity if we're greater than 0. So we have to write a little bit more to make that more clear here. What we got right here, it says if n is a whole number, okay, so it's greater than 0. If n is a whole number, then as we're approaching negative infinity, there's different results here. It says we could be approaching positive infinity or negative infinity, right? Here, let's get rid of this stuff right here. All right, so if n is even, n is odd. So here's our two different answers. It could be infinity, it could be negative infinity, depending on if n is even or if n is odd. So this is still true. We're approaching infinity as we go to the right, but if we're going to the left, we have a condition here. It's either going to be positive towards positive infinity or towards negative infinity. Now there's something else we can say as if n is greater than 0. If the n is negative, if it's a negative number, that means it would go on the bottom of a fraction, right? Right? Okay, now look at this graph right here. This is the x at the bottom of our function right here. That means this x has a negative exponent. It has an exponent of -1. I can rewrite this to say equals x to the -1. So if we have this and we're approaching infinity, what is this function approaching? Tell your neighbors. Now graphically, when we look at this guy right here, that's this graph right here. Graphically, as I'm going to the right side of the graph, it's really clear that this horizontal line is approaching the this function is approaching the horizontal asymptote at 0. Right? It's obvious, yeah? Okay, numerically, I want to think about this for a second. Okay, numerically, let's say we have a fraction and we have this number right here. It's unknown. What is this number? I don't know. But let's say this number is getting really big. It's getting really, really close to, we're going towards infinity. Now that's not a number, but that's a concept. It's saying that this number is getting really, really big. That means you're going 1 divided by a really, really big number. When you have 1 and you divide it by a really, really big number, what is that number really, really close to? Yeah, as we plug in bigger and bigger numbers, that number is going to keep getting closer and closer and closer and closer to 0. Does that make sense to you guys? So if you ever have an x on the bottom of a fraction and you plug infinity in, which you can't really do, but if let's say you do, you plug infinity in, what does it equal? It equals 0. What if we're approaching negative infinity? For the same thing. See the same thing as that? If we're approaching negative infinity, it still goes to 0. Okay, so it's the same thing as when you're approaching positive infinity. All right, those are concepts. Now let's do math. Well, that is math. Never mind.